Hello, welcome to lecture 3. Today I am going to talk about trigonometric function. This is mathematics for class 11, chapter 3 based on NCERT syllabus. My name is Sangam Banerjee and my details are given below. Here I would request students to go through my class 10 maths lecture, that is lecture number 3, where I have given some introduction to trigonometry, and similarly lecture 4 where I have discussed some exercises. And also I would request to go through this lecture 5 where I have discussed circles, tangent and secant. So these are important because if you go through this lecture will become very simple because most of the trigonometric has been discussed in this chapter, and there is one more chapter which is a continuation of this one, part 2 of 2, that is circles, areas of sectors and segments. So please kindly go through these 4 lectures, and mostly what today I am going to say is an extension of what we had discussed in class 10. As you all know that class 11 is an extension of class 10, so kindly go through class 10 lectures so that understanding or following this lecture will be much easier. So let us start. Most of the content we have covered in class 9th and 10th. So let us again repeat it for the sake of completeness. So here we will discuss what is pi. As you know, definition of pi is nothing but is a measure of circumference divided by diameter. That gives you the value of pi. That is 2 pi r divided by 2r, so you get pi. Anyway, we'll go through this in more detail here now. So you know, if you have a circle and this is say some 1 unit, either 1 centimeter or 1 inch, whatever it is. So if you take in 1 centimeter and the length of this arc from A to B is again 1 centimeter, then the angle subtended by this arc here is 1 radian. And if it goes in a counterclockwise, we take it as positive, or if it goes in the clockwise direction here, then we take it as negative sign. And this is the same thing. This also, length of this arc is also 1 unit. Suppose this is 1 centimeter, this also should be 1 centimeter. And here if the length of this arc is 1.5 centimeter, 1.5 some unit, then the angle subtended here will be 1.5 radian. And so you can understand that this is your 0 degree and this 90 degree will come here, and this will be your 180 degree, and the full circle will be your 360 degree, which is nothing but 2 pi. So here you can see that this 2 pi will be here, this 1.5, then again 1.5. For pi you will have say 1.5 plus 1.5 will be 3, slightly more than 3, say it is 3.14, because you can show that the value of pi is 3.14. We will see it just now. And similarly, this 2 pi will be your 3.14 plus 3.14, that is 6.28. So here also the same thing. This is in the negative direction. So as I was saying you that how do you obtain pi? Pi definition is circumference by diameter. So that is circumference is, if I take this diameter this size, so circumference is pi into diameter. So if I plot a graph of circumference by diameter, okay, for various diameter I measure, I cut open this circle here and measure the length and I plot it here, the slope will be my 3.14. okay, so this is the definition of pi. So you understand the meaning of pi now. This is nothing but circumference by diameter is the meaning of pi, and this is always constant. So this is, you see, a constant slope is there. Okay, so this is similar to what we have discussed in class 10 linear function. Y is equal to mx plus c, where m is the slope and c is the intercept, and here you see the intercept will be at 0 and the slope m is your 3.14. So let us continue. Circumference of a circle of radius 1 unit is 2 pi. As I said, this circumference, this is radius is 1 unit, this circumference is 2 pi because r is 1, 2 pi r is 1 is 2 pi. Just one complete revolution of initial side, this is the initial side, subtend an angle of 2 pi radian, as we have discussed earlier. So 2 pi radian is 360 degree, which we said earlier, which implies, now I take this 2 pi this side, so 1 radian is, this is 2 is there, so 360 divided by 2 is 180 degree by pi. And if you do this value you substitute here, you will get 57.3 degree. That is 1 radian. So similarly, 360 divided by 2 is 180. So if I take this 180 this side, so 1 degree will be pi by 180 radians. And so this 2 pi radian by 1 radian, that is equal to this 2 pi radian is 360 degree, which we have said here earlier, and this 1 radian is 57.3. so these degrees and degrees get cancelled. So here it is 6.28. So I can write this 2 pi is equal to 6.28. So let us point out one more thing here, that thus if a circle of radius r, okay, if this is radius is r of this circle and the length of this arc is L, and then this r here also this will be r, so the angle subtended here is say theta, then we can say that this length L is nothing but this radius here r times theta. Why? Because we know that suppose this L is here this much, so L by C will be your same fraction will be theta by 360 degree, okay, in degrees. So here I have written L by C is equal to L by 2 pi r circumference, that is theta by 2 pi. So this 2 pi and 2 pi will get cancelled. So L by r is equal to theta. So L by r is theta, means L equal to r into theta. So to repeat for your benefit, this 360 degree, if you want to convert into radians, you multiply by pi by 180 degree. Okay, this degree will cancel and you will have 2 pi radian. And similarly, you know, this here I have given the method that radian is nothing but, suppose you want to, whatever degrees you have, you want to convert to radian, you multiply by pi by 180. And similarly, if you want to convert, this radian is given to you and you want to convert to degree, you just multiply by 180 degree by pi. How to remember this? This is radian, so this is degree and this degree will get cancelled. So this 180 degree has to be in the denominator. So you will have radian. So you will get the same unit as this left hand side. And here degree is there. So you know you have radian and you want to convert into degree. So again you put this pi radian here. So this radian and radian will cancel and you will get degree. So this is how to remember. Just go through it and try to justify it yourself. Okay. So here I have written degrees: 30 degree, 45 degree, 60, 90, 180. So 30 degree, again if you have given here degree, so I can write this is 30. So 30 will go in 186 times. So you have pi by 6. So similarly 45, it will be 4 times it will go, so pi by 4. So if you know this, you don't have to memorize such table. So you can yourself calculate and find out. Now this 1 degree can be sometime very large angle when you are doing some astronomical measurement. So this 1 degree can be further divided into 60 part. Actually this is some historical reason you break it in 60, because from very early time, from Sumerian time, and it was base 60. So that is called sexagesimal. So you break this 1 degree into first minute part. So this 1 degree is broken into 60. So you say that 1 degree is equal to 60 minutes. Okay, a minute or minute is nothing to do with the time, but it's just a division of this degree. This is called 60 minutes. So one can say that this 15 minute is nothing but 1 by 4th of a degree. So if you have 1 by 4th of a degree, you can write as 15 minutes. But sometimes this also is very large. So again you can break further into second minute, or it's called second. So this is 1 minute is again broken into 60 seconds. So here I have written that 1 degree you can break into 60 minutes, and further each minute you can break into 60 seconds. Okay, so 1 minute is 60 seconds. Again to repeat, this is nothing to do with time. So this is just first minute part, and second means second minute part. Okay, so now let us discuss some example describing what we have discussed here. So here convert 40 degree 20 minute into radian measure. So how do you do it? 40 degree, this 20 minute is 1/3 of a degree. I have done it here, because 60 minute is 1 degree, so it is 1/3. So 1/3 degree. So I can write this as 40 into 3 is 120 plus 1, 121 divided by 3 degrees. So now this degree I can convert to radian, as we have shown earlier here also. So for degree to radian, I write 121 pi by 180. So 180 into 3 is 540. So this quantity is in radian. We have converted this 40 degree 20 minute in radian. So now let us discuss another example, that is 6 radians is 6 into, now I convert this into degree. So how to convert radian to degree? So this is how you do it. 180 degree, I have not written the degree here, it is understood. So it is nothing but this 180 here, and this pi is 22 by 7, that is nothing but 3.14. So sometime we write pi as 3.14, or sometime we write pi as 22 by 7, according to our convenience, whichever we find it easy. So to get rid of this decimal, we are writing like this. So now if I calculate this one, either using calculator, and if you are good in multiplication, kindly do it. If you evaluate this value, you will get 343.6363, which is repeating. So here I have approximated this to 0.64 degree. Here I have put an approximate sign. So this 343 degree, then this is degree I can write in terms of minute because 1 degree is 60 minutes. So I remove this degree and put 60 minutes. And now I can break up, this is 38 minute and 0.4 minute. So 0.4 minute in I can write in 60 seconds, 0.4 into 60 seconds. So now if I add all of them, this in degrees, 38 minutes, 0.4 into 60 seconds, 20%. So here we have converted this 6 radians in degrees, minutes and seconds. And in the previous one, we have converted this degrees and minute to radian. So kindly pause and go through it. So now let us have a quick revision again here. This is degree measure. So if you have this base and if you go counterclockwise, and full rotation if you do it, then it is 360 degree. As we had mentioned that if it goes counterclockwise, you take it as positive, and if you are going in a clockwise direction, this will become minus 360, where I have shown here that this is going here up to 360 and then again you are adding some minus 60, so 360 minus 6 plus of minus 60 will become minus 420. Here it is you are going in a clockwise, so it is minus 30 degree. Here you are going in a counterclockwise 180 degree. So kindly pause it and go through it. Here it is you are going in a counterclockwise, you are going 360 plus again 60, 420 degree. Okay, that's why I have written here see my class 10 lectures also. Now let us discuss what is sine function. This also we have discussed in class 9th and 10th more elaborately. So what is sine function? Suppose you have a circle and there is a point P, and this point P goes along this circumference. So it will have two projection in the x-axis and projection in the y-axis. The length of this projection from this to point this projection here is called the sine function. That is, when this point is here, the projection on y-axis is 0, and as this point moves up, the projection on y-axis will increase, and when this point comes to here 90 degree, that is here this is 0, here this is pi, that is 180 degree, here it is 90 degree. So when it comes here, it is maximum projection, here it will be 1, then again it will go down, and again here when it is pi, it will be 0. So that's what I have shown here, this y-axis, and this is your this angle is theta. So in this axis I have put the theta. So as a function of theta, how the projection goes, so it increases and then goes to maximum, then again it comes to 0, then goes in the negative side, goes minus 1 here, and then again when it completes one rotation here, it is 2 pi or 360 degree. Same thing I have shown here by breaking into many pieces. So these are pi by 6, pi by 3, which we have discussed in our earlier slides. So similarly, as I said, for sine function, this is nothing but a projection on the y-axis. So you can have projection on the x-axis also. This is your cos. This is point P which is projecting on the x-axis. So here the projection is start with maximum, and when it goes to 90 degree, it will become 0. Projection of this point on x-axis will be 0. And similarly, when it goes in the other direction, that is the angle subtended here is pi, it will be minus 1. And when it comes to 270 here, it is 0. The projection of this point on x-axis is 0. And when it again comes back here, it will be again plus 1. So it started with plus 1, it went to minus 1, 0 is in between at pi by 2, and here it is 3 pi by 2, because pi by 2 plus pi by 2 is pi, plus pi by 2 is 3 pi by 2, then 4 pi by 2, 2 pi. Okay. So here again I have, as I have shown here, I have broken into many segments and shown here. So please pause it and look at it how I have plotted it. Now we will discuss this trigonometric table. Actually, I would recommend students to go through my class 9th and 10, and I have shown some tricks using fingers how to remember this table. So kindly go through it, and just for the sake of completeness, I am just showing it here. So let us go it quickly. So here you see this is one more trick is here, that is you start with square root of 0 by 4, 1 by 4, 2 by 4, 3 by 4, 4 by 4 for 0 degrees, 0, 30, 45, 60 and 90. So these are the main, if you see the tables, people remember this one only, 0, 30, not in between, and we will show you how to calculate in between one also. So 0, 30, 45, 60 and 90. So you write 0 by 4, 1 by 4 square root. So if you do this square root, the sine function will be, this is 0. 1 by 4 square root will be half. So go through it. This is very easy. 4 by 4 is 1. 3 by 4 is root of 3 by 2. And 2, this is 1 by 2. So square root of this will be 1 by square root 2. So this is very trivial. So once you know sine, so now you know the cos will be when it is 0. When the sine function we saw was 0, it was 1. So you just replace it here. From this is from left to right. You write same thing right to left. So this is 60 thing will come here, and 30. This is your same, it remains same. This half will come here and this will become 0. So once you know sine and cos, you do the division. Sine by cos is tan. So similarly, this divided by this, you will get this. So kindly do it. This will become infinite somewhere. So kindly go through it. Let us not waste time because we have discussed this many times in class 9, 10, 10. So just for sake of completeness, here we say that of course you make a triangle here, equilateral triangle 60, 60, 60. You break it, you bisect this. So this becomes 30 degree. So once you, these are length A, this is A, this is also A. So this, when you do bisect it, it is A by 2 from this point to this point, and this is also A by 2. So sine of 30 is nothing but your opposite side, that is A by 2 by hypotenuse, which we have discussed elaborately in class 9, 10, 10. So see those definitions. So A by 2 by A will be half. So you get half here. So similarly you do for cos also. Cos is your adjacent side of 30. This is your h, that you can do use Pythagoras and find this h is nothing but square root of 3a by 2. So you kindly go through this. You can pause and or you go back to my class 9, 10, 10 lecture and see how I have derived. It is all derived here. So it is very simple. You just simply pause and see. These are all self-explanatory. And there are some definition like what is cosecant theta, that is 1 by sine theta. We will tell you the meaning of all these things also, what really cosecant means, what really you mean by secant, and this is cot. This is just definition, but this is not the meaning. So inverse of cot is tan, or inverse of tan is cot. So similarly inverse of cos is sec, or sec is inverse of cos, and similarly cosec is inverse of sine, or sine is an inverse of cosec. I can get sine here and this cosec, so sine is inverse of cosec also. So since this I have just simply taken it from my class 9th and 10th standard. So this is a length of an arc S, which we have shown earlier or have seen earlier, that S is, or L is equal to R into theta, which we have done earlier. So here I have written S, and this area is nothing but, as I have shown here, it is this the fraction of theta by 2 pi, okay, and pi r square is the area of this circle. So you have to take the fraction, that is theta by 2 pi times pi r square. So this pi and pi will get cancelled. So you have theta r square by 2. So this sector is a fraction of this pi r square. So what fraction? That is theta divided by 2 pi, the whole thing. So this fraction of area. So I have written here, this is the area and the fraction is theta by 2 pi. Just pause and go through it. Okay, now we take again from class 10 lecture this slide. Okay, so please go through my class 10. There it is discussed more elaborately. I will go here. So here I show few concentric circles. The radius of this red circle is 1, and this is 1.5 of this. The radius of the black circle is 1.5, and the radius of this outer circle is 2. So if you have unit radius here, this is 1. It can be anything, 1 centimeter or 1 inch. So this is 1 unit. So the projection of this point on the x-axis, as we said, is cos, and the projection of this point on the y-axis, we said it is sine theta. Okay, sine of pi by 3. And if you increase the radius, the projection will increase, and you write it as x is equal to r cos theta. So this here, this capital R and this small r is same. And so similarly, as this radius increases, the projection also will increase, but your this cos theta value will remain same, only it will get multiplied by r, this radius r. Okay, so here you see I have written, if suppose you have a hypotenuse and this angle subtended with respect to this horizontal base, which is called adjacent, is say theta, and so the base is adjacent to this theta, so this base is called adjacent side, and opposite to this this theta is called the opposite side, and the longest side is called the hypotenuse. So if the hypotenuse is 1, then cos theta is base upon 1. So that is cos theta will be base or the adjacent side. And similarly, if the hypotenuse is again 1, then opposite side, so sin theta will be opposite side upon hypotenuse. So if hypotenuse is 1, so sin theta will be opposite by 1, that is opposite. So I can write, if this hypotenuse is 1, I can write this as sin theta, this length of opposite side as sin theta, and the length of this adjacent side as cos theta. But if r changes more than unit, then it will definitely change as I have shown here. So this x will be r cos theta and y will be r sin theta. So once this x is r cos theta, y r sin theta, I can substitute here. So depending on the angle, these values will change. Okay, the position of x and y will change, so the value of x and y will change. So from here one can say what will be the equation of a circle. So here if you see, I use Pythagoras theorem. Well, Pythagoras theorem says, suppose this is x and this is y. So x square plus y square is r square. So x is r cos theta and y is r sin theta. So since I said from Pythagoras theorem says x square plus y square, this x square plus y square is this hypotenuse square. So this cos square theta plus sin square theta should be 1, and that is equal to r square. So this is one more equation, that cos square theta plus sin square theta is always equal to 1. As I had said here, if hypotenuse is 1 and I said the adjacent distance is cos theta and the opposite this length is sin theta, so cos square theta plus sin square theta is hypotenuse square. Hypotenuse 1, so is 1 square. So now let us define what is cos theta. As I said, it is adjacent by hypotenuse. Adjacent is x and hypotenuse can be anything. If it is 1, then cos theta is x, as I said earlier. And now suppose if it is not 1, some other value r. So x by r is your cos theta, and similarly sin theta will be y by r, okay, opposite by hypotenuse. And you can define one more quantity called tan theta, which is a ratio of sin theta by cos theta. So if I take a ratio of sin theta by cos theta, you have this. Here I think I made a mistake. It should be y by x. Sin theta is y by r and this is x by r. So this should be y by x. That is equal to opposite side by adjacent side, y by x. Now let us see what is the physical meaning of those trigonometric functions. So again I have taken it from my class 10 lecture. The right angle is denoted by this square here, this 90 degree. And if this angle I denote it as A, and since we know from earlier classes that sum of all the internal angle of a triangle should be 180. So if this is 90 and this is A, then to get 180 I have to add 90 minus A. So this minus A will get cancelled, and 90 plus 90 180. So sum of all the internal angle is 180. So here I show that sine of 90 minus A will be, this is the angle 90 minus A, that will be opposite side upon hypotenuse. What is opposite side? AC upon AB. But this is also same as cos A, because cos A is nothing but adjacent by hypotenuse. So I can always say that sine of 90 degree minus A is nothing but cos A. And similarly cos of 90 minus A is nothing but cos is adjacent side of this angle is BC by AB, and that is equal to sine of A, that is opposite upon hypotenuse, that is BC by AB. So cos of 90 minus A is sine A. So now let us find what are the meaning of the trigonometric function. You see here I have, this is a circle of unit radius, and I have this from O to Q, one segment. Then from this tangent point to this point Q, that is PQ, is another segment. And then you have this from point P to R, and then from O to R. So these are the four things, 1, 2, 3 and 4. And this we have denoted by, this distance we have denoted by sec theta. We will come to it why I am defining it as sec theta. And this distance from here to here I call it as tan theta, and this distance from the tangential point to this point PR is cot theta, and from this point origin to this point R is cosec theta. So physically what it means is, if you draw a tangent to a circle at point P, then the distance from this tangential point where it intersects at x-axis, the distance is nothing but tan theta. And again from this point P, the tangential point, and where the line intersect the y-axis, this distance from here to here is cot theta, and the distance from this origin to where it intersect is called the sec theta, and the distance from this origin to where it intersect, this line intersect the y-axis, is called the cosec theta. So how do we prove this? So you have four of them. I have highlighted here: OR, OQ, PQ and PR. That is, as I said, OR, OQ, then PQ and PR. So I take a triangle OPR, that is OPR, that is nothing but, if this is theta, so this angle is 90 minus theta. So I take sine of 90 minus theta is opposite side, that is PR by OR. So now we have to do little bit of algebra. I use the Pythagoras theorem. This is 90 degree, this angle. So OP square plus PR square is the hypotenuse square, OR square. So where OP I have taken as unit 1. So your PR will be your OR square. This OP is 1. So square root of OR square minus 1, because this is 1. Here I have taken unit radius. So now I can substitute this PR here and take the OR this side. I can write OR is sine 90 minus theta, that is equal to square root of. So now I take a square of it. As I have said here that sine of 90 minus theta, or this A is cos A. So I write here sine of 90 minus theta is cos theta. And since I am squaring to remove this square root, so this cos square theta, and this I have removed the square root by squaring the whole thing. So here OR square I take common here. If I bring it here and minus 1 this side, so 1 is equal to 1 minus cos square theta. And since we have said that sin square theta plus cos square theta is 1, so I can write 1 minus cos square theta is equal to sin square theta. So OR square is 1 by sin square theta. So I can write as OR is equal to 1 by sin theta, because now I'm taking square root on both the sides. Here it was square, so I'm taking a square root. So OR is, this distance is OR, is 1 by sin theta, and this is cosec theta. By definition, inverse of sin theta is cosec theta. So this distance is cosec theta. So similarly, if I take a triangle OPQ here, that is this angle, I take it as, if this is theta, this is 90, this has to be 90 minus theta as I have shown here. So sine of 90 minus theta, this angle opposite side upon hypotenuse. So this is the hypotenuse from here to here, that is OQ. So 1 by OQ, and this distance is 1, which we know. So this OQ is equal to, I can write this, I bring it here, and this sine 90 minus theta, and I know that sine 90 minus theta is cos theta. So I write 1 by cos theta. So this is sec theta. So this is from the definition of sec theta. Sec theta is nothing but inverse of cos theta. So similarly, pause it and go through this. You will know what is the value of PQ and also what is the value of PR. This is PQ is this one, that will come to tan theta, and similarly PR will come to cot theta. So just pause and go through it, and the same is discussed in earlier class 10th. So go through that also. Now let us discuss this trigonometric function. Here I have plotted the projection of the base on the y-axis will become 0. So this is the sinusoidal function, and this is the cos function. At x equal to 0 it is maximum, okay, because it occupies, suppose you have a circle, it is maximum, and as the angle increases, the projection on the x-axis will go down, and when the base rotates by pi by 2, its projection on x-axis will be 0, and when it rotates further and goes to pi 180 degree, it will be maximum minus 1. And similarly, when the point moves to 3 pi by 2 on the circle, the projection on the x-axis will be again 0, and again it will be maximum. The point will have a maximum projection when the point reaches 2 pi. So please go through my earlier figure where I have explained how you generate this kind of function. And inverse of sin x is cosec x. So here you see when it is 0, this will 1 by sin theta is your cosec theta. Here I am writing it as x, theta as x. So it is going to infinity, and as the value of this sine function increases, this will come down, and at this maximum this will have a minimum. This is value is 1. So 1 by sin x, the sin x value is 1 here. So 1 by 1 will be 1 here. Again, the value when it decreases, it will go up, and at here at pi, it will again go to infinity. Now this value becomes negative. So again, you will start from the negative. Here it will be minus 1. And again, when it goes to 0, it will go to infinity. So kindly pause it and try to understand this figure. Similarly, the second also, you take a inverse of cos x, 1 by cos x. This is maximum. This is maximum. And then here it will go to infinity at pi by 2, and at minus pi by 2 also when this goes to 0. Again the sign changes, so it will start from negative sign. So kindly pause it and try to understand what it is. And similarly, tan function, that is sine by cos. Okay, this is sine is here and cos is here. So it is 0. Okay, then it is maximum here, it is 0 here. So 1 by 0 will be going to infinity. So at pi by 2 it will go to infinity. So similarly, in this negative x-axis, here it is minus, and here it is going to 0. So again it will, in the negative direction, it will go to minus infinity. So tan function is like this. So similarly for cot function, which is nothing but cos by sine, the inverse of tan function. So as you know that this is going to infinity here, at pi by 2 it will go to 0 because it's inverse of that. And when this is 0, so at this it will go to infinity, or you can see from here cos and sine, and you can get this kind of figure. So here the interesting thing is that the period, that is one cycle, it is 2 pi, and similarly for cos function it is 2 pi, and here also you see this and this is separated by 2 pi. Actually, let me introduce a concept called phase. Phase is this point here. If you consider this point which I'm showing here, this point and this point are in same phase. That is, its slope and the curvature are same. Okay, so here you see the slope is say 0 and this curvature is same. So this is the period. So here also between this and this they are in same phase. Okay, so there the period is 2 pi. Here again it is same as that, is 2 pi, and here it is actually separation or period is pi. Okay, here I have written period is pi. So you see this phase and this phase, or this point and this one, they are separated by angle pi, and similarly here also period is pi. Now let us come to this equation sin x is equal to sin y. So what is the solution? What are the values of x where this sin x will be sin y? So as I said that I am considering 4 quadrant here. Okay, this is one, this is second quadrant, this is the third quadrant from pi to 3 pi by 2, and from 3 pi by 2 to 2 pi is the fourth quadrant. So I am considering only the four quadrants here, and actually the solutions in this first 4 quadrants are called the principal solutions, and general solution is when you are generalizing up to x is equal to infinity, you can have many solutions. That means for many values of theta you will have same values of f of x. So here let us consider only this first 4 quadrant. So what are the solutions? Solution is x is equal to, suppose you have for say some x value, this is x, you have this, again you have same value for this also. So if you have, this is your x, or I can call it here y, suppose this is y, so another solution you will get at pi minus of this distance y here. So here also you will get it. So this is minus 1. This equation we will try to prove it in coming few slides. So this is the one. It means that x is equal to at this point, and also at pi minus, if n is 1, the first order term we are taking, the first one. So it is at pi minus y, that is at this value also. And similarly for this cos function, suppose you have this value here, suppose this is your some value of x, you have a function f of x having some value here, the next value will be somewhere here. So how do you get it? This x is equal to, here if this is your say distance, say this is y, at 2 pi minus y also you will have the same solution. So we will anyway prove all this in the next few slides, coming slides. Now let us see this sec x is equal to sec y, and what are the solutions? Suppose this x is equal to y, that is I'm considering this x equal to y first here, and the next value will be at 2 pi minus y here. At 2 pi minus y also you will have the same value, and at 2 pi plus y also you will have the same value. So as we progress you will understand what I'm trying to say, or you pause it and try to see what it means. It means that what are the values of x's, you will have same value of this f of x. So similarly for cosec x also, suppose if this is the value, the next value is somewhere here, that is pi minus, this is, I'm taking the first order, so minus 1 to the power 1 is negative, so this is the one. So similarly tan also, tan x is equal to tan y, means at x is equal to, suppose this value, then you add pi plus, so this is pi plus y, so whatever the value y, the first one which I have taken here, first I take x is equal to y. Okay, so this is your y, and the next one will be, you have to add one more pi value. So once you add pi value, you will get the same, this value and this value will be same on the y-axis. Okay, for given this solution, this is for first value and this is the second. I'm only considering the first 4 quadrant, and similarly for cot x, cot y, just go through it. This also we had mentioned in class 10. So suppose you have negative x, at x is negative, so sine of minus x is actually minus of sine x. So whatever value of sine x is there at x is equal to negative. But here you see at for cos x, if for positive x and for negative x, so cos of minus x is also same value on the y-axis. If you have a point here for particular x, you have a cos x value here, and it will be same as cos of minus x will be equal to cos of. Just pause it and kindly see and try to understand this. And we had derived what is sine of a plus b. Okay, this is a trigonometric function, sine of a plus. These are very important thing, and you will be, without this kind of equation you cannot proceed with the trigonometry. So how do you prove sine of a plus b is sine a cos b plus cos a sine b, and similarly cos a plus b is cos a cos b minus sine a sine. So now how do you prove this sine a plus b and cos a plus b? I have shown some diagram. There are various methods. I will show you 2 methods which are easy for me to explain. So suppose you draw a square here, and this diagonal is of 1 unit, and and I have these two line you draw with angle A and angle B, and this is your angle A plus B in this square. So this will be your sine of A plus B will be from this point to this point, that is sine of A plus. Similarly, cos of A plus B will be the adjacent side, okay, for this point here. So this is cos of A plus B. So what is sine of A plus B? Sine of A plus B, this point is actually this distance, sine A cos B. I will show you how you get this value. Sine A cos B plus cos A sine B is sine of A plus B. And similarly, this cos of A plus B will be your cos A dot cos B. This is the one. And this one you subtract it because this is cos of A plus B. From here to this point here, the projection of this point on the x-axis is cos of A plus B. This one. So cos of A plus B is cos A dot cos B minus of sine A times sine B. So how do you get these values which I have shown here? So you start with here this one, and you have this angle. This is your angle B, and this is a right angle triangle. So this length will be cos B because cos B is adjacent side upon hypotenuse. This is 1. So cos B by 1 is your adjacent side, that is cos B. So similarly, sine B will be your opposite side upon hypotenuse is 1. So your opposite side will be sine B, which I have explained. So please kindly go through my these earlier slides. So you have this sine B here, you have cos B here. So similarly here cos A I can write that this is the adjacent side, which I say I do not know. So adjacent side, and this is your hypotenuse for this triangle. So here I have written adjacent side will be your cos A times sine B, which I have written it here. So this. So similarly for this side here, which I have written here, that is sine A is this opposite side upon sine B. So this distance is sine A times sine B. So similarly, if I take this triangle, that is sine A is your this opposite side. So here I have written sine A is your opposite side upon hypotenuse is your cos B. So your this opposite side will be this cos B will come here, sine A times cos B will be your opposite side. And similarly here for cos A, for this triangle, this green triangle here, that is cos A is your this adjacent side by cos B. So I can take cos B this side. So adjacent side is cos A times cos B. So once I know this, of course, as I said earlier, how to, this is cos A plus B is cos A times cos B minus sin A sin B. And similarly sin A plus B, this distance is sin A plus sin B is sin A cos B plus cos A sin B, which I have shown. So similarly, you can show that sin of A minus B, I can write at A plus of minus B, and just pause it and go through it. From here you can get sine of A minus B, and similarly cos of A minus B also you can get from here. The only thing I write plus and minus B. So wherever cos of minus B is cos B and sine of minus B is minus, so here this minus comes, okay. Sine of minus B is minus sin B, cos of minus B is cos B, so it doesn't change the sign. But here you see sine of minus B is minus sin B, so minus times minus will be plus, so here is plus. This is from this odd function and even function. So sine of minus x is equal to minus x is called odd function, cos of minus x is equal to cos x is called the even function, because negative of this one is doesn't change the sign. So as I said, this is another method. So let us go quickly. This is very similar to what we did earlier. So you take a rectangle and you draw two lines from this corner, and you draw this, there is a perpendicular, you draw like this, and if this angle is A and this angle is B, so the adjacent side will be your cos B, okay, as I had mentioned earlier, and similarly the opposite will be sin B, and this is unit. And if this angle is A and this is B, this total angle is A plus B. So since you know that when you draw a line which passes through two parallel lines, this angle A plus B will be equal to this angle A plus B. They are complementary opposite angle which we have studied in class 9. So if this angle is A plus B, then this length will be sine of A plus B, and this length from here to here will be cos of A plus B. And similarly for this angle A, since this is a hypotenuse is sine B, the opposite side will be your sine A times this sine B. Please go through my earlier slides. And similarly your this adjacent side will be cos A times this hypotenuse sine B. And similarly here it will be, this is your say sine A, so sine A times this is your hypotenuse cos B, and again this is your cos A is this one times the hypotenuse. So since I have not written here, I have written something. See here what I mean, any sine theta opposite side by hypotenuse. So if you know the hypotenuse, the opposite side will be hypotenuse times sine theta, and similarly adjacent side will be hypotenuse times cos theta. So kindly go through this and try to figure it out. Now this one I have discussed briefly earlier, so kindly pause it and go through it. So here sine of 90 minus a is opposite side upon hypotenuse, that is AC by AB is cos A, which we have shown. So kindly go through this. So now let us discuss how to use this kind of thing in an example. Here example 9, evaluate tan of 65 degree by cot of 25 degree. So you can use these rules. So tan of 65 and this is your 25, so 90 minus 65 is 25. So cos of 90 minus 65 is again tan 65. This A and A same. This 65 here, this 65. So I can write this cot of 90 minus 65 as tan of 65 degree. So this is equal to 1. So similarly, another example, sine of 3a is equal to cos of a minus 26 degree, where 3a is an acute angle. Acute means less than 90 degree. Find the value of a. So again, similarly, you write sine of 3a is cos of 90 degree minus 3a. So this 90 minus, I have converted this in this form. So now since cos of 90 minus 3 is cos of a minus 26 degree. So I can say that this argument here and this argument is same. Here I have written here. And now I just readjust it. This minus 3 you bring it here 4 here. And this minus 26 you bring it there 116. So a is equal to 29 degree. And here I have just substituted this to find whether this answer is correct. So pause and go through it. And here again these are some of the identities. Sine of 90 plus theta, that is sine of a plus b sine a cos b plus cos a sine b, and sine of 90 degree, that is pi by 2 is always 1, we know it. So sine a cos theta, sine 90 cos theta is cos theta, and then cos of 90 we know projection is 0, so the second term of sine of a plus b goes, so only it remains with cos a. Similarly here say cos of 90 degree is always 0, so this is cos a cos b, so first term is 0, then cos of a plus b is cos a cos b minus sin a sin b. So you have minus sin a is 1, so minus sin theta. So anyway, I remember all these formulas, so it is easy for me, but you better try to remember this formula and try to check whether they are correct. Similarly, cos of 180 degree minus theta, I can write as 90, 180 as 90 plus 90 minus theta. I club this in one, that is cos of 90 plus 90 degree minus theta is nothing but from this here I can get this, and cos of 90 minus theta is minus. So I have used this to get this. And similarly, cos of 270 degree plus theta is, again you can just pause and go through it. These are all simple algebra, that is equal to sine of theta. Okay, so cos of 270 degree plus theta is nothing but sine theta. Now let us revise again this trigonometric identity. As I said that using Pythagoras theorem, that is this AC square plus BC square is equal to AB square. So this is your sine square A plus cos square is equal to 1. So similarly, if you divide this by say cos square, so this will become 1. So this is sine square a by cos square a is tan square a plus 1, and 1 by cos square a is sec square a. So similarly you can do, these are little algebra. This is the main thing. Then you have to divide by some function to get this. And similarly, since sine square a is nothing but 1 minus cos square a, so sine a will be square root of 1 minus cos square. So these are just trivial algebra, so kindly do it. You just have to bring from left hand side to right hand side. If it is square, then you can take a square root at both the sides. So square root of sine square a is sine a. So square root of any square number is the same number. So similarly for tan, sec, cos a. Now let us see some example which you may ask to prove that sec a into 1 minus sine a, this in the bracket equal to 1. So how do you do it? So here this sec a I have written as 1 by cos a and tan a as sine a by cos a. And since in the denominator cos a is common, so I write cos a common, 1 plus sine a. So now I use here a minus b times a plus b is a square minus b square, and this sec a is again 1 by cos a, so it's become cos square a, and we know that 1 minus sin square a is cos square a, so cos square a and cos square a, this cancel, equal to 1. So similarly here also, these are all very similar and very easy thing. So this is cot a minus cos a divided by this. You have to show that this is this. So here just pause and see, this cot a is nothing but cos a by sin a again, and you can bring out cos a as a common, so you have 1 by sin a. So this 1 by sin a is cos a, so this is cos a minus minus 1 and cosec A plus 1. So anyway, we have more or less discussed what we have done in class 10. So let us now go to your main chapter and solve some exercises, because if you know class 10th, you can very easily solve class 11. Now these are all from your book of chapter 3 of class 11. So this is example 3. It's ask find the radius of a circle. This R you have to find it. For suppose this angle theta is 60 degree and this L is. So we use this formula, L is equal to R theta. So R is L by theta. So it is very simple. Kindly go through it. Now this is example 4. The minute hand of a watch is 1.5 centimeter long. How far does its tips move in 40 minutes? So use pi is equal to 3.1. As I said earlier, you can use either 22.7 or 3.14. So whatever they have said, you use that. So again, the solution is very simple. So your length of the arc is R times theta. R is given to you as 1.5 centimeter. And your theta is this 4 by 6 times 2 pi. This I am writing in radian, and this is 4 by 6 because it's 40 minutes. So 60 minutes means 6 by 6 is 1. This is your 4 times 10 minutes, that is 40 minutes, 4 by 6. So this 1.5 goes in 6 4 times, 4 by 4 get cancelled. So you have 2 pi centimeter. That is, as we have said, 2 pi is nothing but 6.28. And anyway, they have told to use the value of pi as 3.14. Now example 5, if the arcs of the same length, the length are same of two circles, and their substance 65 degree and 110 degree at the center, find the ratio of the radius. So this is also very simple. This, and since this lengths are same, I can write R1 times 65 degree is equal to R2 times 110 degree. So then R1 by R2 will be 110 by 65. Here I have written that is 22 by 13. So this is the ratio of the two radius of the circle. Now this example, find the value of sine of 31 times pi by 3. So here solution 31 pi times 3 is nothing but I can write as 10 pi, that is 3 into 10 is 30 pi by 3. So now we know that this is your 10 pi. I can see, as I said, the sine function. This is your sine function. So this is 1 pi, 2 pi, 3 pi. So this is all 0. So I can write sine of 10 pi plus pi by 3 is equal to only sine of pi by 3. So solution is sine of 31 pi by 3. And this pi by 3 value you can find from your table. Now example 9, find the value of cos of minus 1710 degree. So it's very a trick you have to use, this minus 1710. So I take 360 degree into 5, I get 1800. So this my 1800 minus 1710 will give me 90, and I know that cos of 90, that is pi by 2, is 0. Now let us do some more revision, and here we have shown that this is a equation of a circle, that is a square, this is your x square plus y square equal to 1, this is 1. So or I can write a, since this is unit, I can write as cos of x is cos square x plus sin square x is equal to 1. This is the equation of a circle, and now sin x equal to 0 implies that x is equal to n pi. As I said that for all pi, okay, sine the projection, suppose this x goes to 180, this is 1 pi, the projection of this point on y-axis is 0. Similarly, when it completes 2 pi, the projection of this point on y-axis is 0. So again 3 pi, 4 pi, so for n pi where n is an integer. And similarly cos x is equal to 0 for pi by 2, so first pi by 2, then again it comes here, this is 3 pi by 2, so that is 2n plus 1, okay. So n is first 0, so pi by 2, then n is 1, 2 plus 1, 3 pi by 2, and similarly you can continue as I've said for sin x case, and where n is any integer. So now we define another trigonometric function in terms of sine and cosine, which we have said cosec 1 by sin x, provided this is not 0. So that is provided x is not equal to n pi. So sec x is 1 by cos x, provided this is x is not pi by 2 or 3 pi by 2. Similarly sin x, again this cos x should not be 0, otherwise it will blow up. So similarly here sin x should not be 0. So sin x, when it can be 0, when only it is x is equal to n pi. So it should not be equal to n pi. So these are the conditions. And as we have said that cos square x plus sin square x is 1. So using this you can prove this also. Now some sign of trigonometric function. Anyway, this we have explained earlier. Cos of minus x, this is your even function, this is your odd function. Okay, kindly pause it and go through this figure. There are some salient feature here which you can understand. And here you see, as I said, that in the first quadrant 0 to pi by 2, all sine, cos, tangent, cosine, secant, cotangent, everything are positive. But in the second quadrant, only sine and cosec is positive. Sine and cosec. Because anyway, they are inverse of each other. 1 by sine is cosec. But rest of them goes to negative. That is, it is positive here. Sine, you see here it is positive. Okay. In the second quadrant, also sine is positive, but your cosec goes to negative. So one cosec goes to negative, this cosine is negative. So your tangent will also be negative, sine by cos is tangent. So similarly, 1 by cosine is secant, that will be negative. And similarly, since tangent is negative, inverse of tangent, which is cotangent, it also will be negative. So kindly note that from the sign of this sine and cosine, you can know the rest of them. So similarly here, for the third quadrant here, your sine is negative and your cos is also negative. So sine by cos will be positive. So tangent is positive. If tangent is positive, then inverse of tangent, cotangent is also positive. So similarly in the fourth quadrant, your cos is positive, but sine is negative. So cos is positive, sine is negative. So sine by cos, tangent is negative. Your 1 by sine is also negative. But 1 by cosine secant is positive. So from here, what you understand that the function, when it is positive and negative, for whether it is sine, cosine, tangent, cotangent, cosecant. So this is the chart given here. So how do you remember this? I used to remember this as all silver teacup in our school days. Okay, so this is all are positive. So all are positive. Here only silver is positive, that is sine is positive. If sine is positive, 1 by sine will also be positive. Teacup, here only tangent is positive. If tangent is positive, cotangent is also positive. And here only cos is positive. All silver teacup. Here C is cosine is positive. So your second 1 by cos is second, that is also. So these are sometimes very useful when you have to find the sign of the function at different quadrants. Now let us go to the summary of your chapter given in your textbook. So this I have just simply copied and pasted it here instead of writing again. So this is exactly same as in your textbook. So that is, if in a circle of radius r and arc length l, subtend an angle theta, then L is equal to, which we have done it. Radian measure, which we have said, this is pi by 180. If it is radian, you have to multiply the degree with pi by 180. And if it is, you want in degrees, then here top one will be degree. Here top one is in radian because you want in degree. So this radian cancel, you get in degree. This of course we have seen, we have proved all this. We have shown that this is your cos function. It goes 1, 2 pi. Again it will repeat every 2 pi, it will repeat. Similarly sine function also repeat by every 2 pi, n equal to 1, 2 pi, then 4 pi. Just go back to the figure and check it. And we have shown that this is a odd function. Sine of minus x is minus sine x and cos of minus x is cos x. From the function we have seen it. So please go behind and check it. So here I have shown how to prove this. That is cos of 2n pi plus x is cos a plus b is cos a cos b minus sin a sin b. And we know that cos of, suppose this is your 0, then again come 2 pi, 4 pi. So we know this is always 1. So 1 time cos x, and we know that the projection of this point on y axis is 0. So this is 0. So this is 1 time cos x is cos. Similarly sin a plus b here, sin a cos b plus cos a sin b. So here again this sin of 2n pi, this is here the projection of this on y axis 0, so this get cancelled, and cos of 2n pi is 1, we know it here, and this is sin x, so 1 into sin x. So this sin of 2n pi plus x is sin x. So this says that it is repeating every x plus 2n pi times, it is repeating. N can be 1 to any integer. So this is angle sum and difference identities. So we had shown earlier using graphical method, that is cos of x plus y is cos x cos y minus sin x sin y. Similarly here, and cos of pi by 2 minus x is sin x, because cos of pi by 2 into cos of x, so cos of pi by 2 is 0. Then plus sin pi by 2, sin pi by 2 is 1, and sin x. So this is sin x. So similarly, please expand this using this formula. Similarly, sin x plus y also we have done it. So similarly, we have shown all this actually. So kindly go through this, which I have done it earlier. Again, to continue this, if none of the angle x comma y and x plus minus y is an odd multiple of pi by 2. So pi by 2, if you have it, then this is sin by cos. Cos pi by 2 is 0, so it will blow up. So you don't consider this. And we have seen that at pi by 2 and all, this tan function blows up. You go back and see those graphs. So tan of x plus y is this. So how you prove it? Tan of x plus y is sin of x plus y by cos of x plus y. Again, I expand this. Okay. And I can show this. I divide it numerator and denominator by cos x cos y. So I will get tan x. This is this sin x by cos x, and cos y will get cancelled. So you have tan x. Again similarly here cos x will cancel. You will have tan y. So please kindly do it. These are all very simple things. Let me go pretty fast because we have done all this. And cot of x plus y, again same thing. Cos x plus y and sin of x plus y, again divide numerator and denominator by this, and you will get this one. Also you again do the same thing for this. So these are all trivial examples. So once you understand what trigonometry is, so these are trivial exercise which you have to simply use some algebra and try to solve it. Now this is double angle line. Cos of 2x is, so here I have written cos of x plus x, like cos of a plus b is cos a cos b minus sin a sin b. Here I have written cos x minus sin x sin, and we use this cos square x plus sin square x, which we have shown it equal to 1. So I just substitute in one of that. So this is cos square x minus sin square x I have written here, and this quantity also, this is sin square x by cos square x. So this will be cos square x minus sin square x, that is cos of 2x, and this is your sin square x by cos square x. If I do it, this will be sin square x plus cos square x divided by cos square x. So this cos square x in the denominator and cos square x in the denominator will cancel. So this cos square x minus sin square x is cos 2x. So similarly you can use this sin of 2x x plus x. So you can show here is nothing but, so you pause it and go through this kind of steps. So let me not repeat what I have written here. So I'm sure you can understand what I have written here, like sin of x plus 2x is nothing but sin of 3x. So now you expand this sin a cos b plus cos a sin b, what I have written, and you simplify it till you get this answer. This is 3 sin cube minus here, so that is your minus 4 sin cube x and 3 sin x here. So kindly go through it here. This is your tan of x plus y. You can use this as a formula where we have shown earlier how to prove this formula, and some identity sum to product. So this is cos x plus cos y is, suppose you have a sum of this, you can convert to product to 2 cos x plus y by 2 cos of, so x plus y by 2 times cos of x minus y by 2. So here again I have shown how to prove this, that is cos a plus b. I am writing here cos a minus b, so here it will be plus sign. So cos a plus b plus cos of a minus b, so these two will get cancelled. You will have 2 cos a cos b. So if I now substitute this a plus b equal to x and a minus b equal to y, and you solve this simultaneous equation, you will get a equal to x plus y by 2 and b equal to x minus y by 2. So you substitute this a and b here. So you will get cos of x plus cos of y is equal to 2 cos of x plus y by 2, and b is x minus y by 2. So something like, so pause it and go through this, and similarly in the same line you can solve this also. So this is cos of x minus, so here it will be minus, so this thing will get cancelled and you will have sin a sin b. So here it is, and a is x plus y by 2, b is x minus y by 2, what I have done. So kindly please pause and do it yourself. Now let us continue. This is product identities, that is from product to sum. So here I have done cos of x plus y is cos x cos y minus sin x sin y, and cos of x minus y is this. So I can now cancel this. So I have 2 cos x cos y is equal to cos of x plus y plus cos of x minus. So this is what is here. So similarly kindly do all this also. Then sin x is equal to 0, as I had mentioned earlier. This was discussed earlier. Cos x is 0 for this, which we have discussed. Sin x is equal to sin y, we have shown this earlier graphically, but here I have shown how to solve it. This is sin x minus sin y is equal to 0. So here I use this sum to product kind of thing. Sin x minus sin y is 2 cos x plus y by 2 sin of x minus y by 2. Just go behind and have a look at it. So this, I can write this can only be 0 if this term is 0 or this term is 0. So that means if x plus y by 2 is 2n plus 1, because it's cos, which we have shown here, okay, 2n plus 1, or x minus y, this is sine, if it is n pi, which we have shown it here. So now I can equate this. So this 2 and this 2 get cancelled. So I can write x, and this y I bring it here is 2n plus 1 pi minus minus y. This y has gone here. So kindly pause and go through it if I am going too fast. And or x equal to, from here it is 2n pi, and this minus y goes here. So actually now here for this one, this is your odd 2n plus 1. Okay, and this is x is 2n pi, this is even. So I can combine both of them. So I can generalize it at x is equal to n pi, where this n is odd and even both. Okay, so this is 2n plus 1s are always odd. N is 1, 2 into 1 plus 1, 3, then 2 into 2, 4, plus 1 is 5. So these are all odd numbers. So this 2 into 1, 2, then 4. But both are there, so I can write x is equal to n pi and here minus 1. So depending on whether this n is odd or even, the sign will change. So this is what now we have proved it, which I had told orally using graph earlier. So similarly, tan x is equal to tan y also. Kindly pause it and see this explanation whether you can understand, and which I had explained you why it should be that x is equal to n pi plus y. So these are the solution for x is equal to n pi plus y. Just go back and see the solution. Now this half angle identity, this is sine of x by 2 is plus or minus square root of 1 minus cos. How do you do it? So cos x is cos x by 2 plus x by 2, because half of x plus half of x is 1 full x. Now I can split this and simplify this. This is cos of a plus b is cos a cos b minus sin a sin b. So cos of x by 2 times cos of x by 2 is cos square x minus sin square x by 2. Okay, and again I can simplify this as cos square x by 2 is 1 minus sin square x by 2. So I can write 1 minus 2 sin square. 1 sin square x by 2 come from here, 1 minus sin square x by 2, and this one more. So minus 2 sin square x by 2. So if I take this sin square x by 2 on the left hand side and cos x I bring it here, so I have sin square x by 2 is equal to 1 minus cos x by 2. Now I take square root on both the sides, so this becomes sin of x by 2 square root of 1 minus. So you get it. So similarly you do for the rest also. So these are not very difficult. If you understand, this is the main trick. You break into x to x by 2 plus x by 2. Similarly for the rest also you can do it. Now example 20, find solution of sin x is equal to minus root of 3 by 2. So here your solution is given in your textbook. So I've just cut and pasted here for you all to show that these examples given in your textbooks are not very difficult. So this is sin of x is equal to minus root of 3 by 2. So here you see sin of pi by 3 is, from the table we know, is root of 3 by 2. And sin of pi, as I said, it is 180 degree. The projection of that point on the y-axis is 0. So this is 0. And cos of pi, that is the projection of, this is 180 degree, is minus 1. So it is the other side of the origin. So it is minus 1. And we also know that sin of pi plus theta is sin a cos b plus cos a sin b. So use those formula and you will know that because your sin of pi is 0, the first the product term will vanish. So you will have cos of pi. So cos of pi is minus 1 times sin of theta. So minus 1 times sin of theta. So similarly this also. So these things we will use here. So now this square root of 3 by 2 is your sin. So I can write as minus of sin of pi by 3. And I can, since this is minus, I can write the sin of pi plus pi by 3, which we have shown earlier. The sin of pi plus theta is nothing but minus sin theta. Or you can say, see from here, the sin pi sin a cos b plus cos a sin b. You just substitute here. You will see that the first term will vanish and your cos of pi is minus 1. So this minus 1 come from that cos pi value. So this is equal to 3 pi plus pi is 4 pi by 3. So sin of x is 4 pi by 3. So now you know that sin of x is sin of 4 pi by 3. And we know from here sin x equal to sin y, that is valid for x is equal to, this we have proved it, n pi plus or minus. So this y is your 4 pi by 3 here. This is your y. I substitute here. So this is the solution. X is equal to n pi for all n belong to z. Now exercise 3.3. So let us solve this problem here. So, and this table you should by now know how to reproduce it. So I will use this table. So here you see this is your cos x square. Pi by 6 I have it here. So I don't have to worry about it. So sin of pi by 6 is, your pi by 6 is 1 by 2. So square will be 2 times 1 by 4, 2 times 1 by 4. And this is cosec square 7 pi by 6. So you don't have it here. So you do a trick. 7 pi by 6 you can write as pi plus pi by 6. So you know that cosec of pi plus pi by 6. See here we know this sine of pi plus theta is minus sine theta. So cosec of pi plus pi by 6 will be minus cosec of pi by 6. But you are taking a square, so it will become minus, square will become plus. So cosec of pi by 6 is what? So here it is pi by 6. So cosec of pi by 6 is 2. So this is your cosec square. So this is will be 4. So cosec square, this is your pi by 6 is 2. 2 square is 4 times you have cos square pi by 3. So what is pi by 3 is cos is 1 by 2. So square will be 1 by 4. So this 4 and 4 get cancelled and 2 will go into 4 2 times. So 1 by 2 plus 1 half plus 1. So that is 3 by 2. So answer is 3 by 2. So we have solved this. So it's correct. So similarly we will solve only this one. These are all very trivial. This is all you have to use this table and do it as I have shown. So if you know how to do one, only thing these are different functions have been used. The technique is same. So here also you will see that technique is same. This is sine square. This is 3 pi by 4. So we don't have 3 pi by 4. So we have pi by 4. So you can write pi minus pi by 4. That is 4 into pi is 4 pi minus pi is 3. So this is 3 pi by 4. So I know this sine of pi minus pi by 4 will be minus sine of pi by 4. But I am taking a square. So I just write again the same thing. And all these things I can get from the table. Okay, pi by 4, pi by 3 I can get. I put it here, I get value. Kindly see this whether I have put correct values. And then you have here 2. This is sine of pi by 4. So sine of pi by 4, you know, it is 1 by root 2. Square will be half. Okay, so you just simplify and you will get as 1 plus 9, that is equal to 10. So this is also correct. So similarly here sine of 75 you do not know, but you know that is 30 plus 45 is 75. So I write sine of a plus b, that is sine a cos b plus cos a sine b. So all these values I can get here and I can get the answer. Similarly 15 is 45 minus 30. So 45 is there, 30 is there. So I can write this also. I hope you can understand this. So now from 12 to 20, from 12 and 13 use this, a square minus b square is a plus b into a minus b, which you know. A into is a square, then minus ab plus ba. So this 2 will get cancelled and minus b into b is minus b square. So here it is a square minus b square. So a plus b, here I have written sine of 6x and sine of 4x, and a minus b, this minus sign. So this is again you use that formula from sum to product. So 6 plus 4 is 10 by 2 is 5x. So 2 sine of 5x, and then 6 minus 4 divided by 2 is again cos x. So similarly for this also you do it. And once you have done this, you know that sine of 2 theta is 2 sine theta cos theta, which we have shown earlier. So here I use this 2 sine 5x and cos of 5x. So that will be sine of 2 times this 5x. So this is sine of 10x. So similarly 2 sine x, there are 2 of them. One this 2 here and another 2 here. So 2 of sine x and times cos x is sine 2x. So here I have not written the formula. The formula is what I have used here is sine 2 theta is 2 sine theta cos theta. Just write it down and remember it. So now exercise 14. So this 2 sine 4x I have kept it separately. I have taken this and this. That is 6 plus 2 is 8 divided by 2. That is 2 sine 4x I have got it. And then 6 minus 2 is 4. 4 divided by 2 is 2. So this is cos 2x. And this sine 4x I have taken here. So now sine 4x is common. So you have cos 2x plus 1 here. And then this cos 2x I can split as cos of x plus x. That is cos square x minus sin square x. So cos of a plus b is cos a cos b minus sin a sin b. This is what I have, where a and b is same, x. So this is what I got. And so from here now 1 minus sin square x is cos square x. So you have cos square x here and this cos square x, 2 cos square x. So this is the answer. So which we have to prove. That is 2 into 2 is 4 cos square x into sin of 4x. So similarly from 15 to 20 you can do it using these sum identities. Okay. So you have to take a product cos 9 plus 5 by 2 and 9 minus 5 by 2. So kindly go and try to do this. These are very trivial. These are all done in the same line. Okay. And same idea area you use for all. Now let us discuss briefly this exercise 3.4. These 4 problems are there in your exercise here. So here tan x, so find the principal and general solution. So principals are in the first 4 quadrant, and general means you can go to several beyond 2 pi. So we'll give principal and general also. So tan of x is root 3. So tan of x is root 3 means this is pi by 3. So tan of pi by 3 is root 3. And also tan of, as we have shown earlier, that it has a period of pi. So this pi plus pi by 3 is also tan of pi by 3. So your principal solution will be, one will be pi by 3 and another will be 3 pi plus 1 pi, that is 4 pi by 3. So I write pi by 3, 4 pi by 3. And beyond that you have to write as n pi plus pi by 3. Okay, every beyond 2 pi you keep on adding this pi. And similarly here sec x is your 2. 2 you see here, where is 2? 2 sec 2 is here, that is pi by 3. Again this is pi by 3, sec of pi by 3. And since secant also we saw that it is with a period of 2 pi. So kindly go back and see it. So your solutions will be, your particular principal solution will be your pi by 3. So we are considering only the first 4 quadrants, so we will take only the minus term. You pause it and think why I'm saying this. So 3 to 6 minus 1 pi is 5 pi by 3. And since here again, as I said, you have a periodicity of 2 pi for the secant function, so which we have shown earlier. So you can write this. So plus or minus, because it is like we saw is like a parabola. You go to every pi value, then you add this plus or minus pi. So you will have same value. So these are the solutions. So you understand, when you have an equation means you will have various x with same value. So same value on the y-axis you will have for different theta. This one here, this one here. Then again, here also this one here, this one here, this one have same value. Okay, so here are many solutions. Now here cot x is equal to minus square root of 3. So here cot, this is your cot at pi by 6. So at pi by 6, at cot equal to pi by 6 somewhere here, you have square root of 3, and but it is minus, so it will be pi minus of, so it will be pi minus of pi by 6. So this is plus square root of 3, and here at pi minus of this you will have. So this is one principal solution. So here I have written here 6 pi minus pi is 5 pi by 6, and then for every pi. So now if you add pi here, the 6 into pi, 6 pi plus 5 pi is 11 pi by 6. So this takes care of the first 4 quadrant, and then this is a general solution. So similarly for cosec, that is minus 2. So cosec, this is 2 is here. So this is pi by 6. So this is your cosec function here. So at pi by 6, suppose somewhere this pi by 2, so pi by 6 is somewhere here, but it is minus 2, so you have to go, this is pi, so you have to go again same distance, so you will get here as minus 2. So you have x is equal to pi plus again pi plus 6, that will give you the negative value of minus 2. So 6 times pi is 6 pi plus 1 pi, so 7 pi. So this is 7 pi by 6. And the next solution will be, suppose this point here, that is 2 pi minus pi by 6, that is 2 pi minus pi by 6 is 6 into 2 is 12, minus pi is 11 pi by 6. And this is your general solution. So kindly pause and try to understand what I have said looking at the figures and this solution here. Now these are the final exercises here before we finish. So we'll take only these two, this solution 9 and solution 8 we'll discuss. That is, find the general solution for each of the following equations. So since these are all based on similar line, I will not repeat all of them, but only 2 of them I will repeat. So here sin x plus sin 3x, this is a equation, and find the value of x. For what value of x this equation is satisfied. So I take these 2 term and club them, and this term I keep it here. And again from sum to product I do it. 5 plus 1 is 6, divided by 2 is 3, and cos is 5 minus 1 is 4 divided by 2. So these 2 sin 3x I get from here. Sin 3x I have here. So now sin 3x is common. So I have 2 cos 2x plus 1. So either this term has to be 0 or this club term has to be 0. So any number multiplied by 0 is always 0. Either sin of 3x is equal to 0 or 2 cos 2x plus 1 is equal to 0. Or here cos of 2x is minus half. This is plus 1 goes here, become minus 1, and this 2 will go down, so minus half. So this sin of 3x is 0 implies 3x is n pi. So as we had discussed earlier, the sin function at every pi value, the projection of point on y-axis is 0 for point either at 0 degree degree or at 180 degree. So one can write this 3x is equal to n pi. So x is equal to n pi by 3 for n belong to z. And cos of 2x is equal to minus half means it is here, this is half. So at this value 2 pi by 3. So at cos of 2 pi by 3, this is minus half. So this is the negative side. This. So I can write this 2x will be your 2 pi by 3. Then here also at 2 pi minus 2 pi by 3. Then again at here 2 pi plus 2 pi by 3, this line will come here. So again you will have the same value of minus 0.5, that is minus half. So I can write 2x is equal to 2m pi plus or minus. So either minus or you have to add plus 2 pi by 3 for m. So here x is equal to, you divide by 2, this 2 is there. So m pi plus or minus pi by 3. So hence the general solution for given equation is either this n pi by 3, n belong to z, or x is equal to where m and n belong to z. This m pi plus or minus pi by 3 comes from here. So similarly, solution 8 here, sec square 2x is 1 minus tan 2x. This is the equation. So I bring it all to this side and equate it to 0. So one can write from here, this is sec square 2x is 1 plus tan square 2x. You can show this. It's a very trivial thing. So now tan square 2x, this one and this one get cancelled, and this minus tan 2x I get this side. So I can always write this tan of 2x is common. This tan 2x into tan 2x is tan square 2x. Then tan 2x into 1 is this tan 2x. So either this tan 2x should be 0 or this term in the bracket whole thing should be 0. So this is only 0 when 2x is equal to n pi, which we have seen here. Okay, this is 0 for 1 pi, then 2 pi, then 3 pi. So for n pi it is 0. So that means x will be n by 2 by pi. Here it is. Or tan of 2x equal to minus 1. So we know that tan of pi by 4 is 1. So I write minus tan of pi by 4, and minus tan of pi by 4 is nothing but tan of pi minus pi by 4. So this is 4 pi minus pi is 3 pi by 4. That is 2x is equal to n pi plus 3 pi by 4. So I take 2 down. That is x is equal to n pi by 2 plus 3 pi by 8. So this is the general solution, this or this. Okay, now we will stop here and thank you and see you in next lecture.